talk about some real-life examples, and here to help us with that is Chandra from Accenture. He's a project manager for the BGE Analytics project. He's got 10 years worth of experience with utilities around the world, deep expertise in AMI.
Sure. Thanks, Jesse. Hello, everyone. I'll take you through some of the value cases we have implemented so far in our pilot. So starting with the revenue protection business area, we did theft analysis from revenue protection, wherein we identified theft by analyzing consumption on disconnected meters. We identified CIM cases earlier than the normal process. We identified theft where meter was being put out frequently, and we also identified theft where meter was partially bypassed. So far in our pilot, we have investigated around 47 cases and detected theft on 26 out of them, a pretty good number. Some of the value propositions we have seen in the pilot are proactive identification of theft, avoided field calls during theft of energy investigation due to better usage information, and reduced unbilled usage due to early detection of theft and CIM cases. So now I'm going to talk about some of the examples here. So this is an example of theft on disconnected meter. If you see the first highlighted area, there is consumption on the disconnected meter. Then there is field inspection on 27th September 2012, which is indicated by a meter power outage event. At this point, the meter is disconnected again, and after that there is no consumption, which is second highlighted area. So this is an example of partial meter bypass. So if you see here on 5th December 2012, there is meter power outage event, which indicates bridge installation. Then there is a drop in consumption. And then there is field inspection on 27th December 2012, which is indicated by another meter power outage event. At this point, the bridge was removed, and after that, consumption has resumed. So this is an example where meter is being put out frequently. So from 24th September 2012 onwards, meter is being put out on every weekday, which is indicated by meter power outage events. And meter was inspected on 13th November 2012. Based on inspection, what we found was there were scratches on the meter, which indicated that meter was being put out frequently. Subsequently, old meter got replaced with a new meter, and after that, the consumption has resumed, which is evident from the second highlighted area. So for demand response business area, we have identified potential customers with central AC, potential customers with electric water heaters, high energy customers for summer and winter period, and potential non-operational peak reward devices. To identify potential customers with central AC, we created a control group of customers with central AC and test group of customers with similar usage profile. And we did comparative analysis of control group and test group, and that helped us to identify potential customers with central AC devices. Similar analysis was done for electric water heater as well. High energy customers were identified with the help of consumption threshold for summer and winter period, which we got from the business. And non-operational peak reward devices were identified by comparing consumption before, during, and after the peak reward event with a similar day consumption profile without peak reward event. So the difference helped us to identify potential non-operational devices. And some of the demonstrated value propositions for demand response business areas are reduced cost per enrollment for peak reward central AC and electric water heater programs by targeting right customers. So now we have more visibility into the right customers, so that can help us reduce cost per enrollment. Reduced cost to identify and fix non-operational peak reward devices by targeted field activities. So now we do have better insight into which devices are not working, so our field activities are more targeted. And increased capacity and energy value gain for demand response programs by fixing non-operational peak reward device. So by fixing each device, we get some capacity value and energy value gain. So this is another business value from this. Now this is an example of a potential non-operational peak reward device. So if we see, typically there is an increase in consumption during payback hour after the peak reward event. In this case, there is no increase in consumption during payback hour, which indicates a non-operational device. Through field inspection, we confirmed that the device was disconnected and therefore it was not operational. Okay, so with this, I will pause and see if anybody has any question.
Thanks, Chandra, very much. So I did hear from Renee, and she wanted to know if there was anything you could say about the methodology you're using for making your business case. Is there a standard template or a sort of standard way you calculate that might be helpful for them?
So to build the business case, actually we have developed a template. It's based out of the Excel. What we are doing is we are having discussion with the users, and we have analyzed the pilot results, and based on those pilot results we are framing some hypotheses and assumptions, and based on those assumptions we are building the business case. But we haven't used any standard tool. It's inbuilt in-house.
Okay, thank you. So Mark wants to know if there's anything you can say about costs or about paybacks, or at very least how you're calculating and what you think might be a typical payback for some of these early pilots.
So we are still in investigation. At this point of time, it's really challenging to comment on that. So I can get back to you on that maybe a couple of weeks down the line. Okay. But we are doing the investigation on that.
Terrific. And for those who have asked, yes, we will have our email addresses up at the end if you want to reach out. So Gregory had a question about regulatory involvement. Does this require permission from the regulators, or afterwards will you be requesting authorizations to roll them out in a broader way?
I have limited visibility into that, so maybe I'll ask Matt or Tom to chime in for this particular question.
So Jesse, was the question with regard to the analytics pilot or the smart grid program overall?
No, I think it was about the analytics, if there's any regulatory issues.
No, we don't see any at this point. It's just using the data that we already have and using it for improving business operations internally.
So Alyssa had asked if the theft is identified visually or if the analysis includes models that alert the staff to investigate a specific meter.
Now these analytic tests that Chandra described were identified by the analytics tool. We then sent them to our test of energy field group for confirmation. They then went out and confirmed that there was indeed theft. Another benefit is that once the theft is identified and the service is restored to normal operation, they can use the analytics tool to keep an eye on the following pattern to see if the customer attempts to reestablish the bypass or a theft arrangement.
Okay, so let's continue because Chandra's got some more great use cases, value cases to tell us about.
Thanks, Jesse. So for customer planning business area, we did some voltage analysis wherein we identified meters with high voltage and meters with low voltage. So if we see a typical residential meter, line to neutral voltage range is 240 volt plus minus 5%, and this range can vary depending on the business requirement. So what we did was we identified any meter indicating voltage above 252 volt for at least 25 consecutive intervals as high voltage meter, and any meter indicating voltage below 228 volt for at least 25 consecutive intervals as low voltage meter. And we investigated 3 high voltage cases. In one case, one meter indicated high voltage, and we investigated the associated transformer and found that all meters connected to that particular transformer were indicating high voltage. So we subsequently got that transformer replaced. In another example, 2 meters connected to same feeder indicated high voltage. So we did field investigation and found that the associated capacitor bank itself was supplying high voltage. So we got that fixed subsequently. So these results can help identify some of the issues with the asset which can be looked into proactively and fixed before it gets into emergency condition. One low voltage case was investigated where we found that the line voltage was okay, but the meter type was not appropriate for the premise. So the meter got replaced as incorrect meter type. Some of the value we have seen from voltage analysis are improved customer satisfaction due to proactive identification and resolution of voltage related issues, and improved supply quality due to better voltage management. So these are examples of high voltage and low voltage cases. If you see in the upper diagram, we found several meters connected to the same transformer indicating high voltage. So the transformer got replaced, and the voltage dip in the diagram is indicative of transformer replacement. After we replaced the transformer, the voltage supply was in normal range. In the lower diagram, an incorrect meter type was installed on the premise. So actually, a residential meter was installed on a small residential premise, and a small residential premise needs a different type of meter altogether. So we replaced the meter subsequently as incorrect meter type. For smart grid operations business area, we identified unknown net metering customers by analyzing meter reverse events. We identified IMU mismatch by analyzing consumption. We identified incorrectly programmed net meters by analyzing receive channel. So if the meter is programmed incorrectly, there won't be any receive channel. And we also identified malfunctioning meters by analyzing unique rebooter events. So far we have investigated around 196 cases, and we found 8 cases where customers have installed solar panels, but they were not registered as net metering customers. And this is a typical safety issue. 5 meters were found reversed and installed upside down. 75 wrong IME installations were identified. 4 net meters were identified with wrong programs. So these are potential high bill complaints. If the meter is not programmed correctly, the customer doesn't get the credit for its own generation, which might subsequently result into high bill complaints. And we also identified around 104 malfunctioning meters by analyzing unique rebooter events. Some of the value propositions we have seen are reduced cost to identify unknown net metering customers and malfunctioning meters, reduced unbilled usage due to early identification of stopped and defective meters. Now, unbilled usage is a typical challenge for every utility, so this analysis can be very helpful to reduce the unbilled usage. Another value was reduced customer satisfaction due to proactive identification and resolution of metering issues. So now we are more proactive to identify issues and resolve them, and improved safety by proactive identification of net metering customers. So this is an example of incorrect IMU installation on gas meters. Typically, the specific type of gas meters needs to be fitted with specific type of IMUs to ensure that IMU is capturing the correct usage and communicating the correct usage. If wrong IMU is installed on a gas meter, it does not register the usage and indicates zero consumption. In the example which is given here, the register read is static, which indicates zero usage. But this is not due to no usage at the premise. This is because of IMU mismatch. We validated that by pulling out information from our asset management system, which is Maximo, about the gas meter and the wrong IMU type installed on the gas meter.